First of all, second period, I'm very sorry. After I saw you guys struggle with this sheet, I wanted to go ahead and go over this because I went over it with sixth period and it seemed to help them understand a little bit better. Sorry, the cat has decided you guys need to hear her voice. So I wanted to go over part of this just to make sure that it was clear kind of what I intended for you guys to do with this sheet. So water always moves from hypotonic to hypertonic, and I wanted that to be something that kind of stuck in you guys' heads. Keep in mind that in this diagram, the label at the top refers to the solution. So the solution that a cell sits in is going to be hypotonic. So for example, in this first blank, you're going to put that the extracellular environment is hypotonic to the intracellular solution. The same thing would go for this next column where you would say the extracellular environment is isotonic to the solution, and also for the final column where the extracellular environment is hypertonic. So that's what you're meant to put there. Then remember, these are comparative terms. So hypotonic means there's less solute, which means that the interior of the cell needs to be the opposite. So if the exterior environment is hypotonic, then the interior environment is going to comparatively be hypertonic. And with us remembering that water always moves from hypo to hyper, you can use this key that we've kind of made at the top to try and help you figure out where water is going to move. So the hypotonic solution is outside the cell, the hypertonic solution is inside the cell, which means water is going to move to the interior of the cell. So water moves into the cell. When that happens, let's first draw the diagram. So when water is rushing into a cell, what's going to happen is it's going to burst. And here is my attempt at drawing a burst cell. Also note that we had water rushing into the cell, which is why it is going to be like this. And so that is our lysed cell. The cell is going to be lysed. Then I usually like to go from the hypotonic solution to look at the hypertonic solution, since isotonic solutions are a little different. So if the extracellular environment is hypertonic to the other solution, then the interior environment is going to be the opposite. It's going to be hypotonic. Water always moves from hypo to hyper, so it's going to move from the inside of the cell to the outside the cell, so water moves out of the cell. When water moves out of the cell, it becomes shriveled or crenated. And kind of drawing that, you end up with a little raisin-looking cell. And water was rushing out. Okay? Then if we go to look at the isotonic solution. Iso means equal, so that means both solutions are going to be isotonic to each other. And that means water moves both into and out of the cell. And for an animal cell, this means the cell is normal. So if we look, this cell right here that I'm pointing at, that is your animal cell before it's placed in the solution. So we're basically just drawing that animal cell again. And for every bit of water you have entering the cell, an equal amount should exit the cell. Then you have your plant cell right here, which is what the cell originally looks like. And I'm going to go ahead and provide the terms, but I'm going to let you guys do the sketches for the plant cells yourself. If water is moving into the plant cell, then it's going to be turgid. That means it's stiff or rigid. It's completely full. And so the cell wall is not going to have any give. If the solution that the plant cell is sitting in is isotonic, then the cell is going to be flaccid. Meaning it's basically going to be kind of wilted. The cell is not going to support a lot of weight on top of it. Apologies for the coughing. If a cell is flaccid, then that means that you could kind of poke it and the cell wall would have a little give to it. Then, if you have a cell sitting in a hypertonic solution, for a plant cell, that means the cell is plasmolysed. So I'm hopeful that that helps you guys out and lets you figure out how to finish this. If you need a new copy of this sheet because you wrote in pen or it's too difficult to erase, I found a few more copies, so feel free to ask me in class.